So once you go through all the quantum mechanics and you get the quantum numbers, you're able to build up the periodic table using this alpha principle that we went through and get the electron configurations for the neutral elements. And so that gives rise to the shape of the periodic table that we're all familiar with. Remember that the F blocks are just put down below here. They're kind of out of place. It's just so that the table isn't so wide, okay? But the expanded format would have, elements 58 through 71 right through here, and the actinides 90 through 103 right in there. So it'd be much, much longer. That's called the expanded format. This is called the condensed format. There are some common names used for a lot of the groups of the periodic table. We know, and we'll see very shortly, that elements in the same column, group, family, whatever name you want to use, column, group, and family, have similar properties. And so they have they're oftentimes given names. There's numerical names you can give them. There's a bunch of different conventions. I'm not going to have you, be concerned about which is this group 13 or is this group 4A or group 3A or group 3. That's not really important to me, but I do expect you to know these common names. Okay, so the first group is called the alkali metals. Doesn't include hydrogen. Hydrogen is kind of a loner by himself because it's a non-metal, but lithium through francium have a lot of similar properties and are called the alkali metals. Beryllium through radium are the alkaline earth metals. The chalcogens are oxygen through livermorium, but really the ones we care about are oxygen, sulfur, selenium, and tellurium. Polonium and livermorium are both radioactive. And then there's the halogens. Technically, that's going from fluorine to tennessine, but we really only care about fluorine, chlorine, bromine, and iodine. Astatine and tennessine are both highly radioactive. And then the noble gases, going from helium to oganesson, but again, you don't really have to worry about Og or radon. Okay, so we're just going from helium to xenon. All these metals in the center here are called transition metals. Sometimes we will talk about the early transition metals. It just kind of means the first half of these on the left-hand side versus the late transition metals on the right side. And then we have what I'm just calling other P block elements. Sometimes people just call this the boron group or the carbon group or the nitrogen group. There is a fairly little term used for the nitrogen elements called phinctogens. It's a pretty funny word that starts with PN, but most people don't use that term, so I just put it here on the slides. And then you have the lanthanides, the first row of the F blocks, and the actinides. Most of the actinides are very, actually they're all radioactive. So yeah, that's sort of the big picture organization of the periodic table. We're going to talk about a bunch of different periodic trends. And so the first is the metallic character. And so with the exception of hydrogen, all the elements on the left side of the periodic table are metals. And what does that mean, right? It means they conduct electrons, they have metallic bonds, they conduct electricity very well, they tend to be able to heat up very easily. There's other properties, right? They're ductile, you can hammer them out into wires. Some of them may be very reactive, some of them very like sodium, some of them may be very noble, like gold, but they all have these metallic-like characteristics in common. On the right hand of the periodic table are your nonmetals. A lot of these are gases, like the noble gases, but some of them aren't. Carbon is a notable one, phosphorus. Let's see, what other ones aren't gases? Sulfur, selenium, bromine's a liquid. Of all the liquid at room temperature, iodine is a solid, although it sublimes really easily, turns into a gas. And then in between, you have the metalloids, also called the semi-metals. They have properties that are in between those of the non-metals and the metals. I should say the non-metals are insulating. They don't conduct electricity, that means. And the metalloids have a little bit of conducting. That's why they're called conducting behavior. That's why they're called semi-metals. Those are boron, silicon, germanium, arsenic, antimony, tellurium, polonium. And these ones here, livermorium, tennessine, oganesson, people really don't know, especially 116, 117, 118. So few atoms of those have ever been made. Polonium is a semiconductor, but these, I don't really know if anybody can say for sure right now how to classify 116 to 118. But you can see there's this staircase type behavior. The dividing line between metals and non-metals shifts to the right as you go lower in the periodic table.